All right, class, so with this part of the notes, you have a few different options. If you want to try to edit this with the drawing tool in your Google Docs, you can do that. You can insert a picture and use the scribble tool. If so, you'll need to delete the chlorine atoms. You could also just print it out like I've done right here. That's going to be the fastest way. Or you can write it out completely on paper and then just insert the picture later. I'm just going to show you the way I would do it. Alright, so we have Cl2, it's 2 chlorine atoms. That means I've got 7 valence electrons for each chlorine atom because it's in group 17. I've got 2 of those, so 7 times 2 gives me 14 valence electrons. First step is always to count. Then we're going to connect them with a line to form our skeleton. After the skeleton, we're going to take care of the outsiders. Both chlorine atoms are outsiders right now. So we want to divide these electrons evenly between the 2 chlorine atoms. I just used 2 of them and I've got 14 total to use. So that's 2, 4, 6, 8, 10, 12, 14. Alright, the next step would be leftovers. If I had any leftovers, which I don't, I used all 14, then I would put them on the central atom. We also want to check if they're happy. Do we see any atoms that are unhappy, that don't have enough electrons? And that's not the case. We have 8 valence electrons around each chlorine, so this is a complete structure. Let's look at oxygen, O2. Oxygen's in group 16, so 6 valence electrons times 2 gives us 12. That's how many electrons I have to work with. Let's start with a single bond between them. All right, that's 2 valence electrons. Go to the outsiders. 2, 4, 6, 8, 10, and then 12. Well, we see a problem here because one oxygen has 8 valence electrons around it, but the other one only has 6. So we just took care of the outsiders. We don't have any leftovers, so we move on to the step that says happy. Are they happy? Well, this one is not. So what we can do is borrow a couple electrons from the happy atom and move it down so it can share with the other one. I'm going to redraw this structure to show what I've got. And this is what our final structure ought to look like. Do a final check. 2, 4, 6, 8 around that oxygen. 2, 4, 6, 8 around that oxygen. Let's move on to CCl4. CCl4, we have 4 valence electrons for carbon, plus chlorine has 7 times 4, so that would be 28 plus 4 gives us 32. Okay, to complete the skeleton, carbon is in the middle. We're connecting each of the chlorines to the carbon with 2 electrons. So that's 2, 4, 6, 8 that have been used. Let's put the rest on the outsiders until they have an octet. So 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. Each chlorine has 8 valence electrons around it now. Each carbon has 8 valence electrons around it, and we used all 32 electrons. Everyone's happy. This is a complete structure. Let's go on to H2O. By the way, if you're getting comfortable with this, you may want to choose to pause the video, check the answer, and if it matches, you can skip part of the description. But if you don't get the right answer, you go back and watch it in more detail. H2O, we've got 1 for each hydrogen. We're multiplying by 2, and then we're going to add 6 valence electrons for oxygen. So we have 2 plus 6. That gives us 8 valence electrons that we have to work with. Start by connecting these to complete the skeleton. Now we want to make our outsiders happy. Our outsiders both happen to be hydrogen, which only wants 2 valence electrons. So they're already satisfied by the bond. I would never add extra dots on hydrogen. So after the outsiders, we look to the leftovers. So we have used 4 valence electrons. We've got 4 more, and the leftovers always go on the central atom after the outsiders are satisfied. So we have 2, 4, 6, 8. Oxygen has an octet. Each hydrogen has 2, which is what it wants. This is the complete structure because everybody is happy. Let's look at SO3 with a -2 charge. Pay attention to the charge. Don't forget about that. So sulfur has 6 valence electrons because it's in group 16, and we're going to add 6 valence electrons for each oxygen because it's also in group 16, multiplied by 3 because there are 3 oxygens, and because I have a -2 charge, a negative ion means that it's got extra electrons. It's got 2 extra electrons. So we have 18 plus 2 would give me 20, plus 6 is 26. So I have 26 valence electrons that I can work with. And we've got brackets around this because it is an ion. I could go ahead now if I wanted to and skip ahead, and don't forget it's going to have a -2 charge. Now let's go ahead and connect each oxygen to sulfur with a line. That was 6 valence electrons. I've got 20 to go. So that's 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now all of my outsiders are satisfied, but I still have 2 extra electrons. Leftovers go on the central atom. So I'm going to move those last 2 electrons to sulfur. So we did skeleton, outsiders, and then leftovers go on the central atom. Now we check to see if everyone's happy. Oxygen is happy in every case because it's got 8 valence electrons, and sulfur also has 8 valence electrons. It's happy. Let's go on to number 6, SO3. It looks like the same thing, but there's no -2 charge. So that's 6 plus 6 times 3, but I don't add the extra 2 electrons because it does not have a charge. So 6 times 3 is 18, plus 6 is 24. Got 24 electrons to work with. 2, 4, 6 to get us started off. To the outsiders we go 8, 10, 12, 14, 16, 18, 20, 22, and 24. Next thing we're going to do is put the leftovers on the central atom. Well, I used all 24 of them, so I don't have any leftovers. The next thing that you do is ask if everyone's happy. Well, every oxygen is, but sulfur only has 6. Remember, they want to get 8. So what I can do is I can pick from any of these oxygen atoms and have any of the oxygen atoms share a pair of electrons. I'm going to go with this pair of electrons and move it down here to make a bond. I'll just use a little white out. If you have a pencil, you could erase it. And instead of having 2 dots, we're going to put a line to share those electrons instead. Again, you could have done that here or here by removing one of the pairs of electrons on the adjacent oxygen atom. You get to choose. This is something called resonance that we'll discuss later. Okay, moving on to CO2, number 7. Number 7, we've got 4 valence electrons for carbon plus 6 for each oxygen. We're going to double that because of the subscript of 2. So 12 plus 4 is 16. I've got 16 valence electrons that I get to work with. So I'm going to put 2, 4. Now my skeleton is finished. look at the outsiders. So 2, 4, 6, 8, 10, 12, 14, 16. And I'm out of electrons. I've used all 16. Any leftovers would go on the central atom, but I don't have any leftovers, so we ask, is everyone happy? Oxygen is happy. This oxygen is happy. Carbon is not. See that carbon is lacking some electrons. It's only got 4 and it wants 8. So I'm going to take 2 electrons from here and put it there. Let's see what happens when I do that. See, oxygen still gets to count those electrons because it's 2, 4, 6, 8. Carbon has 2, 4, 6. We're getting closer, but we're not there yet. So I'm going to go to the other side of carbon. I see that this oxygen has a full octet. I could borrow a couple of its electrons. Let's do that. Not borrow, share a couple of its electrons. 2, 4, 6, 8 for oxygen, and 2, 4, 6, 8 for carbon, 2, 4, 6, 8 for the other oxygen. This is what it needs to look like. That's a complete octet. Now let's look at some kind of weird ones. Okay, so I'm giving you the structure of C2H6, the skeleton. We just need to fill it in. Okay, well, I've got 2 carbons. Both of them are kind of in the center. Times 4 plus, and I've got 6 hydrogens times 1. Okay, so 6 plus 8, 14. Now let's go ahead and connect each of these atoms and count as we go. So we have 2, 4, 6, 8, 10, 12, 14. Each hydrogen is connected to one of the carbons, and the 2 carbons are connected together. 2, 4, 6, 8, 10, 12, 14. We used all of our electrons up. Now each hydrogen wants 2, and it's got 2. And each carbon wants 8, and it's got 8. So we're done. Let's look at N2O4. Nitrogen is in group 15, so it's got 5 valence electrons multiplied by 2, and oxygen has 6 valence electrons multiplied by 4. So I have 6 times 4 is 24, plus 5 times 2 is 10. 24 plus 10 gives me 34. This one's going to be a little bit tricky maybe. Let's see. Start by making our skeleton. It's 2, 4, 6, 8, 10. I've still got 24 to go. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 4. I think I miscounted. That should be 34 right there. All right, so all the oxygens are happy, but nitrogen is not. Each nitrogen has 6. So what I can do is borrow a couple electrons from here to make a double bond. And there's a couple different ways you could do this. You could have picked from this oxygen also. And I can borrow from, let's say, this oxygen and make a double bond there. Don't forget, when you make a double bond, you've got to erase 2 dots. When you make an extra bond, you've got to erase 2 dots. All right, and let's double check. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Everyone's happy, and I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. I've used the right number of electrons, and everyone is happy. That's the correct structure for number 9. The next page we're going to be drawing the skeleton from scratch.